Hello, everybody. Good morning, good evening, good afternoon, and welcome to Neo4j Live. Today, building model native apps with Hypermode and Neo4j. And I'm super happy to have famous guests on this show. I think you're one of those that have been here the most often. It's
I think
Will Lyon.
Jesus has to win
Well,
that
okay,
one, right?
Jesus. Well, on the Neo4j Live series, I think you are with 3 or 4 appearances now. You're on the top spot.
Nice. I like it.
How's it going, Will? How are you doing today?
I'm good. I'm great. I was just hanging out with Jason and Naya from the Neo4j DevRel team last night after a meetup in Menlo Park. That was super
Cool.
fun, and yeah, doing good today.
That's great. And I know we usually start. Well, we should still be starting with this. Is the journey and maybe what's currently driving you. So maybe we don't have to talk as much about why you are in the graph circle, why you are interested in what happens around graph databases. So if people don't know, Will had been a former colleague at Neo4j in the developer relations team and is now at Hypermode in the developer relations team. So obviously there's the connection to graphs. But what is it you currently doing? What is most interesting in your life, in work life, I guess?
Yeah, well, I think like largely like we're still working very much in the graph space at Hypermode and still working with Neo4j. I think what we're building at Hypermode is really an AI platform and developer tools around that. We'll talk a little bit about some of these things, but really like the focus is digging deeper and deeper into how folks are interested in using knowledge graphs for AI workflows, which has been honestly like a big learning experience for me, just seeing like the different problems that folks are trying to solve. And I think really like what we're looking at now is this idea of leveraging knowledge graphs for these agentic AI workflows, where the models are helping us make decisions, but really with a focus on keeping humans in the loop. Like from what I've seen, these agents that you just like turn loose to solve some problem don't really live up to that hype. And what
Yeah.
we're seeing with users and customers that we're building things for is we really need to prioritize the human domain expertise, which was a big takeaway. We did a hands-on sprint with a customer building something out over a couple days, and that was like a major takeaway for me, is like being able to enhance that workflow using AI and knowledge graphs as much as possible, but still like allow humans with that, in this case it was like design expertise, to come in and apply that in a scalable way. So anyway, that's a bit of like rambling, but I think that's really like what I think is most interesting at the moment in this like knowledge graph AI space right now for me.
Yeah. Yeah, cool. I think it's very funny because, when the Gen AI cycle kind of started a couple of years ago, and everybody was like, "Oh, this is gonna be great, and everything is gonna be so easy," and now people were worried, okay, this is gonna take away all these jobs, and it's gonna be amazing at the same time. So worried and amazing, and then okay, well, actually, no, it's not gonna work like that. But then, agentic AI, this is the new thing. Okay, you have to just add a couple of agents to it, and then it's all gonna work out fine. Still quite not quite there yet. I think you still need that domain expert, that internal domain specific knowledge. I mean, taking steps towards a more and more automated systems, I think still it's gonna get there. But I think it's very important to state that it is taking away cumbersome jobs, and it's taking away all of these, looking over at specifically domain specific knowledge. I think it's just a huge thing. I mean, just imagine you are a supply company of parts, or a pharma company, or whatever else you do, or a bank. You have probably a plethora of documents and information and data, and overseeing that and making sense out of that is going to be tricky. And if you have an agentic system and that can help you search, help you find connections, get into the data, but understands your domain and doesn't come up with stupid ideas and concepts that are not really relevant for you or don't really make any sense for the domain you're looking to answer challenges or whatever else. It's gonna, I think it's gonna drastically change jobs. I still think this whole is gonna take away my job. I think it's still gonna be nonsense. You just do different things.
I think we should run a hackathon with the focus of replace someone's job by building an AI agent with Hypermode and Neo4j to sort of like to sort of like push this point of like, okay, actually demonstrate, like build something and write a blog post about it that demonstrates like how you actually plan to like replace a job that a human does today. I think that would be really interesting, right? To see like how far could you actually get to, because this is like, you know, a lot of the, as you say, the hype and discussion and the concern is like, how is this going to impact, you know, the jobs that people do? And I would love to see some like actual technical examples of this. I think that would be a fun one to experiment with. We'll just say that.
Yeah, for sure. Yeah, I think that's going to be interesting. And yeah, I'm very excited about this whole agentic workflow and what it brings, and how you make things available that have been very difficult to make available. I mean, we had, and you remember this at Neo4j, we always had this, okay, make sense out of your data, get relationships and make that a first class citizen in your database, or in when you work with data, and actually have access to this data, have not only access but also, you know, make use of that, what you have here. And with AI, I think this is now a bit more understandable for everybody. Like you said, a knowledge graph concept was always something we talked about, but now I think more and more people are aware of, okay, I want to do something AI, I want to do something there, but I also want to use my own data. I want to use my own knowledge, my own domain expertise here. How do I connect it? And a knowledge graph is an integral part of this journey. At least that's what we think.
Totally. Yeah, absolutely.
Cool. There's a comment I need to read out to you, Will, because this is probably a shout back to the good old times from Tim. Will was instrumental in me starting with GraphQL in Neo4j. Great guy. So yeah, I can I can remember
Nice.
the GraphQL stuff we did a while back.
Totally, yeah, and actually we're going to talk a bit about GraphQL today, so this will be a good one.
That's definitely. All right. That was enough rambling, probably from us two. You're here to hear about building model native apps with Hypermode. So I guess we can get ready and dive in here. So let's do that. Here we go.
Cool. Yeah. Great. Yeah, well, the slides are there if you want to pull those down, and feel free to, you know, jump in and ask questions. I can see some of the chat. Alex, I'm sure you can see the chat on all the forums, and definitely interrupt me if interesting points come up. Definitely want to keep this as interactive as possible. So like Alex said, my name's Will. I work on the developer experience team at a startup called Hypermode. We'll talk about some of the things we're working on at Hypermode in a minute. And I'm also, they tell me, a Neo4j ninja, which is, Alex, how would you describe the Neo4j ninja program? Like a way to highlight active community members? Is that kind of the idea?
Exactly, that's the idea. We have this program to, it's like a mixture between Neo4j community members and Neo4j ambassadors who are talking about Neo4j at conferences, who are writing blog posts, who do videos, and who kind of like bring out the knowledge and the story of Neo4j to the world, and are, you know, obviously supported by Neo4j, but not sponsored or paid by Neo4j. So it's a community effort.
Cool. Yeah. So at Hypermode, like really our goal is to be an AI platform to enable developers to put we call them this concept model native apps into production. So apps that leverage AI along with things like knowledge graphs and interacting with data sources, model hosting. Like these are all sort of pieces that you need to put AI into production. And our goal is to uh, support that ecosystem by building as many open source developer infrastructure and developer tools as we can. And these are all open source projects that you can use and deploy on-prem or deploy on any cloud service of your choice. But then our goal is for Hypermode to be the best experience for hosting these model native apps. And what we're going to talk about mostly today is Modus, which is an open source serverless API framework that we build and maintain at Hypermode. And we're going to talk a bit about the motivation of Modus and then how we use Modus along with Neo4j and what that looks like in the context of knowledge graphs for AI. So, like, what is this idea of a model native app? I think if we look back at the way that we used to build applications, this 3-tier architecture, right, where we have client, application, server, and then a database. Where if we want to scale this, we sort of need to spin up another instance of the application server. We need to think about, okay, we need to put a load balancer in front of that and to balance requests. We're often working with like relational databases that weren't really meant to be distributed. So scaling there has some complexity. And like these pieces in the 3-tier architecture, these things still exist, but the difference now is the abstractions that developers think about are different. So we talk about this idea of a serverless framework where the abstractions we think about as a developer is functions rather than writing full applications managing servers. We also think about AI models as a first-class citizen in our applications now. So we need common abstractions for working with models that allow us to test new models, test new model providers without changing our application code. And then, of course, we also want to be able to incorporate knowledge graphs along with that. So we need abstractions for working with knowledge graphs. Knowledge graphs, I think this audience is pretty familiar with this term. I think there's lots of debate and discussion on like what exactly is a knowledge graph. Like what components do you need to actually call something a knowledge graph? Do you need an ontology and all these sorts of things? And in my mind, like a knowledge graph is just an instance of a property graph where we have labels that define like the type of thing, the type of node. We store arbitrary key value pair properties on nodes and relationships, connect nodes. We can also store relationships or also store properties on relationships. The most important like takeaway though, I think for the concept of a knowledge graph is that we have some canonical representation of the thing. So in this graph, this was an example from the FOSDEM conference. So I was in Belgium for FOSDEM a couple of weeks ago. I gave a talk about building agentic GraphQL APIs. David Allen, also Neo4j Ninja, former coworker at Neo4j, was also there. He gave another talk. We share the same topic, right? So we're both talking about LLMs. We both previously worked for Neo4j. We're both at this conference. And so rather than duplicating the thing, as we have new data observation, rather than say like duplicating, I don't know, the topic tag, like we just create another relationship to that. And that allows us to traverse the graph to discover knowledge and meaning. So that's the most important thing, I think, is that you have the canonical representation of the thing. So let's go back to Modus. If we look at kind of what Modus is doing. So Modus is this serverless API framework. I write functions. Currently, Modus supports AssemblyScript, which is a TypeScript-like language, and Go. We're adding other languages soon. So this is one of the goals of Modus, is to be polyglot and support multiple target languages. We use WebAssembly to do that. So when you write a function, Modus will then compile that to WebAssembly. Modus uses introspection of the types that you define in your functions and the signature of your functions to generate one unified GraphQL API. So I said we were going to talk a little bit about GraphQL. This is one of the interesting things that Modus does with GraphQL, is generate the schema based on the functions you define. And then at query time, the generated GraphQL mutation and query fields map to the functions and types that we've defined in our functions, which is quite cool. So we're using GraphQL with Modus, which is interesting. Like I think GraphQL had a lot of adoption early on when it was open source. So GraphQL is this API query language. I think when GraphQL was initially open sourced in, I want to say 2015, 2016 maybe, Facebook was using GraphQL internally. I think there was a bit of confusion on like what actually is GraphQL promising to deliver. A lot of experimentation. I was at Neo4j at the time, working on extensions and integrations with the database, and worked on some of the early integrations with GraphQL and Neo4j, and as a result of that work, wrote this book, Full Stack GraphQL, which is published by Manning, which talks all about how to build these full stack applications with GraphQL and Neo4j. And like there are a lot of interesting takeaways. The biggest one is that GraphQL makes this observation that your application data is a graph, and we should allow the clients to traverse that graph and express what data they want to bring back to, say, like populate the view of an application. There are lots of, I think, nice developer ergonomics in GraphQL, and there are also lots of interesting things we can do mapping GraphQL to the types that we define in our application code, because GraphQL has a strict schema. So the way we're talking about GraphQL with Modus is a bit of a different take than how we were thinking of GraphQL with the Neo4j integration. So rather than integrating like directly with a database and generating database queries from GraphQL, the way we use GraphQL and Modus is generating the API layer. So you don't have to think about what your endpoints or the fields you're defining in GraphQL. That's all just sort of stitched together naturally from the types and signature of your functions. So an interesting approach that I think is quite nice for building that unified API. So if we look at the components of Modus and in the development environments, most of our interactions as a developer with Modus are with the CLI, which we'll look at in a minute. And the CLI handles downloading like the latest runtime, fetching the SDK, depending on what language we're developing with. We write sort of our app source code as these functions. And then as I said earlier, there's this compile step where our app is compiled to WebAssembly, which we can then put in production, either in Hypermode or anywhere that we can deploy WebAssembly code. If we drill down into the architecture of the runtime in Modus, there's this idea of host services. These are mostly like our connections to data sources, to model providers, either models hosted on the Hypermode platform or third-party model providers like OpenAI, Anthropic, these sorts of things. One thing that's a big benefit of WebAssembly, or I should say of the way that Modus uses WebAssembly, is that we can support multiple languages. So you can write your Modus functions in several different languages, and then those are still compiled to the same GraphQL API for the end users. I'd say the end users of your API. But because we're using WebAssembly with Modus, every function invocation, so every query or mutation to the GraphQL endpoint, has its own sort of memory safe sandbox in as a result of WASM. So you don't have to worry about sort of like anything untoward happening with sort of like noisy neighbors or accessing secrets or that function doing anything that it shouldn't have access to. Each invocation of that has its own sandbox memory space, which is a benefit of WebAssembly, which is interesting. For the GraphQL execution layer, I should say Modus the runtime itself is written in Go, although you don't necessarily need to use Go to use it, but we implement Modus in Go and use a lot of the GraphQL Go tools, which I think the WonderGraph folks maintain. So let's take a look at how we actually do something with Modus. So like I said, most of our interactions in the development environment are with the Modus CLI. Let's take a look at this. So the first step is going to be to install the Modus CLI using npm. So you do need to have Node installed to work with the Modus CLI. And then we'll have lots of commands. So I have this Modus CLI and the various commands here. But to start a new app, we're going to say Modus new. And the first thing I need to do is select what language we want to use. Currently, like I said, we support Go and AssemblyScript, but we're adding more languages like Python. Going forward, let's do AssemblyScript. And we'll just pick the defaults here. So the Modus CLI is going to make sure we have the latest version of the SDK and create a new skeleton for our app. So we'll see there. So here's kind of the skeleton of our Modus project. A couple of interesting files here. One is this modus.json file. So this is our app manifest, where we're going to define, first of all, like what endpoints we want to generate. We're going to generate a GraphQL endpoint. We also want to define any like models that we're going to use here or any connections to databases and data sources. Because, again, we're using WebAssembly, which is secure by default. We also like need to specify any external connections like HTTP calls or things like this that we want to make explicit endpoints. Those are not going to be enabled by default, which I think is a big security benefit here. The other file that we'll look at here is this index.ts file. So this is our very basic hello world function. So this is a like TypeScript function that takes an optional argument and returns a string, hello world, or hello name if we pass that in. So the very like basic Modus app here. So we'll say Modus dev. This is going to compile our very basic hello world example into WebAssembly, generate a GraphQL schema based on the signature of that function, and then serve a GraphQL endpoint locally. And we can go to localhost 8686, if I can type here, to the Modus API Explorer. And so this is like a tool for browsing local Modus APIs. You can see the functions and the GraphQL endpoints that were defined. I can invoke this, back hello world, or I can pass hello Will, and I get back, yep, hello Will. Okay, cool. So that's the like very basic example of Modus, which is perhaps not super interesting. We'll look at more complex example in a second here, but I want to kind of set the context of like what can I actually do with Modus? Like what's it designed for? And so back to this concept of model native apps, I think the main takeaway here of what is a model native app? Well, it's a modern like application that has sort of first-class citizen abstractions for working with models in our app. So like language models, embedding models, classification models, these sorts of things. And there, I think, are some common patterns or building blocks. Patterns might be a better word than building blocks, but this is kind of like the 3 steps how I see it of what you can build with a model native app using Modus and knowledge graphs. The first is kind of chaining data and LLMs together. So the LLM, the language model, knows about what it's been trained on. There's a cutoff date, so it doesn't have like recent information that's out there in the world, but oftentimes what's more relevant here is it doesn't have access to your internal data. So it doesn't have access to internal enterprise data. And so we can, based on the query or like whatever problem we're trying to solve, we can fetch internal data or more recent data and provide that to the LLM as context in our prompt. This general idea is called RAG, retrieval augmented generation. There are different approaches for figuring out like what is relevant. Sometimes we'll use embeddings here. Sometimes we'll have like more concrete representation of like how to fetch relevant data. But the basic idea is we fetch internal data and provide that in context in our LLM call. That's kind of like step one, what I see here. The second is implementing like a very basic starting point for agentic systems, agentic workflows. And this is enabled by function calling, or tool use is another term for this, where we are describing tools that the model can use. We say, hey, here are some functions you can call. Here are some other APIs. Here are some databases you have access to. Figure out like basically like an execution plan for what functions to call, and based on the data that comes back, figure out how to resolve this query or resolve this prompt. And this is like the very basic start of building agentic systems. And then the third piece here is knowledge GraphRAG, where we're enhancing our ability for finding the relevant data, the relevant context from our internal data that we're passing to the LLM, based on not just like doing an embedding and a vector search, but we're actually traversing a knowledge graph to find the relevant information to include there. And if you're in the Neo4j community, I know Neo4j has done a lot of like interesting leading work here on defining various knowledge graph patterns and building GraphRAG tooling and these sorts of things. So there are lots of Neo4j resources to dig into there. So let's go through a few examples of each one of these using Modus, just to kind of understand these in a bit more detail. And so the first one we'll look at is this like basic RAG implementation, this basic idea of chaining together internal data and an LLM call. And the example we're going to look at here is for a online blogging app. So one thing that I think is really important about Modus and this idea of model native apps is we're not talking about starting from scratch and building a completely new application. Like Modus is designed to be incrementally adoptable. So in this example, we have our online blogging application. You can imagine, I don't know, something like Medium or WordPress, right? You have like a web app where you're typing in text to publish a blog, like a CMS, I guess is what you might call this. And we want to add some features to this. So we want to add AI generated SEO meta tags. So if you've ever done this, like these are the description meta HTML tags that you add to your blog post, and these are meant to be structured in a certain way to be optimized for SEO. And there's a certain art to writing these. So we're going to have the LLM generate this based on the content of the post that we're writing. And then the other thing we want is to generate suggested titles based on the blog post that we're writing. But here's where the internal data comes in, is that we want to do this in the style of the author. And so we're going to need to retrieve from the database that backs the blogging application. We're going to retrieve information about the author, either like all of their previous posts, all their previous titles, maybe their bio, something like that. So that's the first example we're going to look at. And so I'm going to switch over to my code editor here. So this is a GitHub repo that I pulled down called Modus Recipes, which I'll link in a second. I think I have that on the next slide, maybe. Which has just a bunch of examples of things you can build in Modus. Cool. And so the one we're going to start with is Modus Press. And I guess let's take a look at the code here, first of all, see what we're going to do. First of all, let's look at Modus JSON. So we said in Modus JSON that we're defining our models that we're using. We're defining our connections to other databases and so on. So we're saying we're going to generate a GraphQL API. We're going to use the open source Meta Llama model. So this is an LLM that was released by Meta. We're going to host this on Hypermode. So the Hypermode platform can host open source models. We can grab any models from Hugging Face. So that's the provider here. And then we're also going to connect to a local Postgres database. And so I have a Postgres database running locally that just has the backend for this fictitious, by the way, blogging application. But the same concepts apply here. So that's our app manifest. And then let's look at the actual code here. So this is assembly script, which is very similar to TypeScript. And so you can see here the Modus SDK, we have clients for Postgres. We have this models abstraction for working with OpenAI compliance models. And we have a few functions here. So we have this generate SEO function, which takes post content. So this is going to be the content of our blog post. And this is the prompt, right? So generate SEO meta tag. You're an SEO expert. And then this gen title one, this is going to go to our Postgres database, retrieve information about the author. So in the style of this author, using their biography and the category of the post and so on. And then we have a helper function here, generate text, which is what's actually invoking the model. So grabbing the model that we defined here in our app manifest, basically just invoking that. And then we have a helper function for querying Postgres.
Cool.
So let's give this a Modus dev. So that's going to compile our Modus app, and we get an error because I need to stop this app. So I had this app running. They want to run on the same port. So we'll just stop that one and then try it again. So that compiled our app. We can see here, like the GraphQL endpoint is running. See the functions that were defined. So these helper functions, like get author by name and generate text, like these are not exposed in our GraphQL API because they're not exported. Only the functions exported get included in the generated GraphQL API. So now if we go to the API Explorer, give this a refresh, we have two new fields, generate SEO and generate title. And so let's say I wrote a blog post about the history of San Francisco, or in this case, I asked Claude to do that. And we want to generate the SEO optimized meta tag for that. We would just pass in the content of the blog, and here's the meta tag. In this case, I have the temperature, which is kind of like the creativity parameter parameter turned up pretty high, so we get pretty different results each time, which is always fun. Okay, and then the generate title. So the same content. We'll say this is the travel category, and we want to look up William Lyon as the author. So here's suggested title: Dramatic Transformations: How San Francisco Reinvented Itself from Gold Rush to Tech Hub. And again, each invocation gets slightly different generated title. Yeah. Cool. So that's the very basic example of chaining data and LLMs together. The next step is getting the building blocks for like a very basic agentic system in place using function calling or tool use. And this is where the LLM is actually making a decision about control flow of our application. It's actually looking at tools or functions that it can call, deciding sort of how to handle that. So like this is the default case where we're using a language model. We're passing it a prompt and we get back some output. With tool use, we have tools that the LLM can call, and if it chooses to call a tool, then we feed the data, the result of that tool call, back to the LLM, which then decides, do I want to call any of the tools that I have, or are we done? Have we resolved the query? In that case, then we'll send the output. That's the basic idea. And so we'll look at another example from our Modus recipes repo here. So we'll stop that one. And this one is, I think, just called function calling. Very, very descriptive naming. So this one, if we look at our app manifest, this one we're going to use an OpenAI model. So we define the model we want to use, which is GPT-4o, and we need an API key for OpenAI, which I've set as an environment variable here. So the idea here in this app, if we take a look, first we'll start at this warehouse.ts file. So this is going to be a basic warehouse example where we're going to have products in the warehouse, and products have like a quantity and price. So we define that type here. And we're going to define two functions. One is get product types. So what are the products types that we have? And then for a given product type or multiple types, tell me the quantity and price. And so like super simple, just an object here with shoes, hats, trousers, shirts, quantity and price of each. So these are going to be the tools, these functions. So if we go here into index.ts, we'll come back to that prompt in a second. Here's where we're defining these as tools. So we give a little description to the LLM of what each of these two functions that we defined: get product list, get product info. We tell the LLM like this is the kind of information this function returns, so that it knows when to invoke that function and when not to. And then this is the prompt that we give it. So you're a warehouse manager, answering questions about stock and price of the products. You can call some tools, try to be helpful to user questions. Mm-hmm. So let's run this one. And function calling. Let's get in the right directory. And Modus dev. So this will compile my project and start a GraphQL API. Go back to our API Explorer. And so now I have one endpoint, one query field, which is ask question to warehouse. And I can say something like, what can you help me with? And and the LM says, hey, I can, based on the prompt that was given, like, this is what I know about. I know about stock and price of products in a warehouse. And I can ask questions like, okay, well, how many outfits can I buy if I have $2,000? And we added some like debugging here in this logs array, which gives the kind of path that the LLM
Okay.
takes to
Yeah,
resolve this.
that's cool.
So first it's calling get product list. And then we see this is what comes back from the get product list function: shoe, hat, trouser, shirt. And then it's saying, okay, great, give me product info for each of these, and get back the price, quantity, and so on. And so the ultimate response here is, well, if you have $2,000, you can buy 2 outfits consisting of shoe, hat, trouser, and shirt.
You only
And we
get
can ask. That's true. I think it's implied that there are 2 shoes and a set of shoe. What's interesting here is we can ask like a bit more complicated questions, like, okay, how many outfits can I buy if I have $2,000 and I don't wear hats? So we didn't specify like what is a complete outfit. The model just sort of inferred that, well, an outfit is going to be hat, shoe, pants, shirt. This one, let's try this again here. Okay, so previously with $2,000, I could get 2 outfits, right? When I was buying shirt, trouser, shoes, and hat. But now, knowing that, hey, I don't wear hats, I can get 5 outfits if I'm excluding the hat. So you can imagine where you can go from here if you sort of think of any database, any API as a tool that we can describe and give to the model. The model is able to call those to sort of retrieve and reason about the data that comes back.
Yeah, that's pretty cool. I specifically like the way that you are also making it very transparent what it's doing, so you can follow that reasoning or that what's happening in the background. I mean, for the end user, I think this is obviously too much. But when you're developing this, it's great to see. Okay, does it actually do the things I want it to do? Does it call the right places? And is this repeatable exercise and not just some fluke?
Totally. What's interesting is you typically get the same like ultimate response, but if you look at the execution plan, like the path that these tools were invoked, it's often very different, right? Like sometimes the model will ask for the prices of everything at once. Sometimes it will ask one by one, and this sort of thing. So I find that kind of interesting.
Yeah, I mean, you could always. I think the application is relatively loosely defined here in this case. I think you have just said, okay, here are the functions. Pick whatever functions you want. I guess you could kind of like define it a little bit more and can say, okay, this is a typical question. People will ask about the total price of outfits. This is what you should be doing. Call this this tool first, and then call this tool next, to give it a bit more of a, I guess, streamlined experience, so that it doesn't go, you do whatever you want. But yeah.
Totally. Yeah. The prompt is super vague here. And it's the prompt engineering aspect, I think really has a big difference. And the idea of even like providing, few shot reasoning where we're like, here's the format of the typical response. We did that with the SEO meta tag, right? Like here's the format, an example of a reasonable response, that sort of thing. Yeah, that's a whole nother area to think about, this idea of optimizing your prompts.
Oh yes, yeah.
Cool. So that is function calling or tool use, which I think of as kind of the basic getting started point for implementing an agentic system. The third building block or pattern here is this idea of knowledge graph RAG, and this is where Neo4j comes in. So, like I said, Neo4j I think has done a lot of leading work in building tools to enable graph RAG, both with Neo4j and general tooling and putting concepts out there. This GraphRAG.com site, I think, is a really good resource to see some of the patterns and ideas. But at a high level, like the idea of knowledge graph RAG is, okay, I am chaining my like internal data together with an LLM call. I'm not just using, like in the example we showed here of a single query from a database. I'm maybe doing like an embedding vector search to find a starting point for a traversal in the graph, but then I'm traversing the knowledge graph to find the relevant information, the relevant internal information to include in the context of my LLM call. And this is often crossing the boundaries of this concept of the lexical and the domain graphs. And this is common if I have a bunch of unstructured data, like documents or something like that. I'm going to chunk those. I'm going to generate embeddings. I'm going to do entity extraction to connect those to my domain graph. So maybe I have, I don't know, information about organizations or companies that are mentioned in documents. I'm going to link those with relationships to those canonical representations of those companies in my domain graph. Maybe I don't know, I'm building like a stock trading agent and I have a knowledge graph of like what companies are competitors and suppliers. And I'm looking at maybe doing like vector search on news reports. That's my lexical graph where I'm just sort of starting that piece from a search in vector space. But anyway, lots of like interesting patterns that you can follow there. The example that I want to show here is simpler than that concept of looking at news and company knowledge graph. We're going to look at a movie recommendation app using data in Neo4j. This is the recommendations sandbox. If you've spun up Neo4j sandbox, there's recommendations is one of the data sets, which combines a data set about movies and user ratings of those movies that comes from Movie Lens. And so what we're going to do is generate embeddings based on the plot, I think is the field, the plot of each movie. So like the description of the movie. We're going to use Modus and a model hosted on Hypermode to generate embedding, which is a vector, so a whole bunch of numbers, store that back in Neo4j, and then use Neo4j's vector search to find similar movies for a simple recommendation app.
Cool.
Oh yeah, and the code for that is here, but let's switch back to our code. And this one is, we have a Neo4j Modus starter kit that has a backend and a front end. I'm going to go ahead and start the backend piece, and we'll take a look at that. Let's look at the code here. So I want Neo4j starter kit, backend. We'll start by looking at Modus JSON. So our app manifest. And in this case, we're using the mini LM model. This is an embedding model for generating embeddings. And then we're declaring a connection to Neo4j, reading from environment variables. In this case, this is just a Neo4j instance I have running locally, but you could use Neo4j Sandbox or Aura, wherever you want to host Neo4j.
Cool.
And then in our code, we have some helper functions. So one here is generate embeddings, where we're taking in an array of strings, invoking the model to generate embeddings, and then returning that. And then we use this generate embeddings helper function when we're generating embeddings for all of the movies in Neo4j. So we're looking for movie nodes that don't have an embedding, that have a plot, and we're paginating these, sort of starting with the highest rated movies first. Basically, is what we're doing here. Doing those in batches of 100, which is, I found, like about a reasonable size for invoking the mini LM model. Kind of depends on what exactly you're trying to embed, but that worked for me. And then we're creating a vector index in Neo4j. So Neo4j supports multiple types of indexes. One of those is a vector index for doing vector search, so similarity search in vector space based on an embedding property. But we need to define that index first in order to do that similarity search. So based on that, let's see what this looks like in the API Explorer. So I have a few functions here. One is generate embeddings. So this is my helper function that's going to generate embeddings by invoking that mini LM model that's hosted on Hypermode. And I don't know, so this is going to be like the plot of a movie. I don't know, like best adventure movie ever, whatever. This is what actual embeddings look like, right? It's just like an array of numbers, which doesn't really mean anything to us, but has lots of like really important context encoded in it, which is kind of a super fascinating area to get into. Okay, so then the other piece of this, which we didn't see yet, is find similar movies. So what we're going to do here is say, okay, you have just watched a movie, or there's a movie that you like. We want to generate a recommendation by finding a similar movie, in this case as defined as like a similar movie in vector space, so where the embeddings are similar. And we can do that using Neo4j's vector search. This is the syntax for that. db.index.vector.query nodes, and the name of the index that we defined above. And then this piece is just formatting the result. We also are going to fetch like the actors and the genres of that movie as well. And that's basically that piece. So if we look at that query field, find similar movies, if I just watched movie Cosmos and I want 10 recommendations, I'm going to get brief history of time. We also get the score, right? So this is like a measure of how similar these two movies are, and that sort of thing. This one also has a front end, so we can look at that really quick. This is a Next.js app that uses Apollo client, like the GraphQL client, to query this endpoint. I think it's running here. Yeah, cool. And so there's a couple of pieces here. One is that I can generate the embeddings. This is going to find movie nodes that don't have an embedding property and calculate those. But my database, I already ran this for all of them, so there's 0 to update. And then I can search for my Cosmos movie, and here are my recommended movies that I get back based on that. And this all comes from the data in Neo4j. So just kind of like a getting started example that just shows like how the pieces fit together. We built this initially for an event we did with Neo4j and folks at Boundary, some other folks in Seattle for kind of like a mini hack night. So this is kind of like a starter kit for that. I think you guys are having Vibov from Boundary on soon, right?
Exactly. Yeah.
Another episode.
That's next week.
Cool. Yeah. That should be a good one. I'll tune in for that one. Yeah, BAML's super interesting. Cool. Okay, so that's that. Like again, this is like a starter kit. So I think like what would be interesting to go from here is like, okay, we did this like vector search to find similar movies. Now let's traverse the graph to, in this case, say, okay, well, people who rated this movie highly also rated other movies highly, or maybe look at overlapping actors, like basically crossing that lexical graph into the domain graph by traversing it using the similarity search as kind of a starting point for your traversal. That's kind of how I think of how indexes in general are used in a graph database, right? Use the indexes to find the starting point and then traverse out from there. Cool. Anyway, so the code is in this this GitHub repos, or this Modus recipes repo. Hype.foo/recipes is the short link for that. So there's examples that I showed today. There's also examples for doing RAG and on like Markdown, lots of other sort of getting started examples of things you can build with Modus. And a last chance for the slide here. I'm not sure how we're doing on time or questions, but that's pretty much all I had at this point.
Cool. Thank you very much, Will. I put the links to the slides as well to the GitHub repo link. I'll put it in the chat as well as in the YouTube video description. So if you're wondering where to find those, then there will be, or they are already in the YouTube description. I saw a couple of comments. Seha says, for application that require complex relationships, Neo4j is the optimal choice. She's currently building a social media backend API for a mobile application using Neo4j Aura and Node.js for her thesis. So it's very cool.
Nice.
Let us know how that goes. And Abdullah says, and I don't know if you know this, I don't know this top of mind right now, is GraphRAG using N8N possible through Neo4j as the database? I don't know what N8N is, to be very honest with you. Have you heard about this?
Is that internationalization? Maybe what they're referring to.
Maybe.
I'm not sure, actually.
Yeah, okay. Well, sorry, Abdullah, we don't know this exactly, but you can take this question to the Neo4j community. Maybe somebody knows more about this there. Yeah, I don't see any other questions right now. So where can, if people are trying this and have questions to you or around Hypermode and Modus in particularly, anything you can point people to?
Yeah, folks can join our Discord, which I should add to the slide here. It's discord.hypermode.com is the URL for that. That's a great place to connect with any of the Hypermode folks or any of the community folks sharing what they've built. There's like lots of interesting discussions going on there, people sharing projects. We did a few hackathons over the last couple of months, and so there are lots of interesting hackathon projects that folks have been building, and a lot of those projects have continued on into more real world projects that people are trying to build startups around or
Cool.
put products into production. So lots of cool things going on in the Discord. But yeah, it's probably the best place to connect with us and the Hypermode community there.
Cool. Perfect. That's great. So what that leaves me with, you already teased it a little bit earlier. The next stream, upcoming stream, is happening on the 25th of February. So that is next week. I think that's Tuesday next week, where the lovely folks at BAML, Boundary ML, are joining us to talk about generating graph data from unstructured data. That will be done on the Tuesday next week, same times. So if you are interested in learning more about this unstructured data and how to do, incorporate that in your application flow, then join the stream next week. And from our side, obviously, if you want to know more, learn more, the Graph Academy is a place to learn, get hands-on with interesting interactive courses from Neo4j introduction to Gen AI development, graph application development, and so on. There's also some stuff on GraphQL with Neo4j, so it's a good a good place to start. Neo4j RDB free is our offering as a graph database in the cloud. So if you don't want to install anything, you don't want to mess around with managing the instance yourself, just go there. You get a free instance and you can just get in. And similar to Will's point about Discord, we have a Discord server, we have a community forum. Check out those if you have questions around Neo4j, if you want to know more and have stumbling blocks, questions, or maybe just want to share what you're doing with the community and showcase a little bit of your current work. And yeah, I think with that, we're at the end of this episode. Thank you very much, Will, again, for participating, for spending the time, and for showing us the cool demo. I think it's a very fascinating field, and cool applications can be built with this stack. So I'm looking forward to what you all gonna build in the future, and maybe some cool companies, or at least some cool solutions.
For sure, yeah. Let us know in the comments if you're watching the recording on YouTube, like what some interesting things you would want to build with Neo4j and Modus. Yeah, or definitely ping me on Discord and let me know if you're digging in, or anything we can do to help. I think it's like a super fascinating time to be a software developer these days, like with sort of the acceleration in AI, and it's really fascinating to be a part of it. So thanks, Alex, for hosting, and thanks everyone for joining today.
Cool. Thank you very much, Will. Take care, everybody. Have a good rest of your day, rest of the week, and see you next Tuesday, hopefully. Until then, bye-bye.